Guess what? You're all here. I'm so excited. Okay, we're gonna do two warm-ups. I just put this up because I figured you forgot how to do the warm-up, so I just have to work on them. Um, we're going to do number 17 and 19. Okay, guys, both of these two warm-ups say the word arithmetic in them. Arithmetics use the same formula. I'm going to put it over here. Sum equals n over 2 first term plus last term. Just going to throw it over there in the margin. Several times, yeah. But I figured, it's been a minute. Okay, so for this one, n is 5. I can tell because it starts at 1 and ends at 5, and there are 5 numbers between 1 and 5, including 1. Okay, the first term is what I get when I plug 1 into the equation here. So 10 times 1 minus 20 is negative 10. I think. Keep your eye on me. I haven't done any math in like 11 days or something.
How hard for you to read the formula is, in the second thing for you to start to negative, or is that the key? That's the key, right?
Yeah. And to get the last term, I plug in the last spot number, which is 5. Okay, sum equals 5 over 2, negative 10 plus 30. Okay, any questions about number 17? Did I do number 17 correctly? Did anyone else get 50? Okay, just checking. It's been a hot minute. Okay, now down here, determine the number of terms n in each arithmetic series. N is what we're solving for this time, and they gave us the sum. So 1365 equals n over 2. Okay, and the first term is what I'm going to get when I plug in 1, because it's telling me it starts at 1. 3 times 1 minus 1 is 2, I believe. T of n is what I would get when I plug in n. So I don't know what n is. So that would be 3n minus 1. This is that old quad formula one you love so dearly. Okay, so 1365 equals n over 2. And the first thing I do is combine the 2 and the -1, so I'm going to go 3n plus 1. Times 2 on both sides. Distribute. Get it equal to 0. N equals -b plus or minus square root b squared minus 4a c all over 2a. Okay, now in this case, I think you guys remember, I hope that this has to be a whole number, otherwise I did something wrong. So I'm just gonna go ahead and type this whole dealio in. And then hopefully you also remember that you only have to worry about the plus. Well, n is the number of spots. So you're not going to have a negative number of spots for a positive sum.
You're right.
Okay. Any questions about number 19? I know it's been a little while, but we already had a quiz on it at least. I think, never mind. Okay. So, now if you guys could find the stamp sheet side. I need you guys to look at what the homework is, please. It is a worksheet. We're going to do this right now, 151 to 153 with notes on the binomial theorem. And we're going to use a resource page to start. Hopefully you noticed that from my notebook being up there. This problem is 10-151. Okay. Today we're going to talk about something that's completely unnecessary for your education. But it's one of those things that if you can figure out how to use it properly, it'll make you a lot smarter in certain problems. Today's lesson is how to avoid significant amounts of large boxes. Okay, so if you love to do the box, you know, like multiply out a 2 by 3 or 3 by 3 box or something like that. If the box is your jam, You might not love it. I don't love to do giant boxes, so I'm looking for a shortcut. Luckily, a mathematician figured out a shortcut for us, and his name is Pascal. And here's Pascal. I have him as a visual aid. He's not going to teach you anything, sadly, but he is Pascal. Okay, so does anybody remember? Probably not what this notation is here. We learned it the first day of chapter 10. Combination. Okay, so I thought it would be helpful for us to just, you don't flip your paper, don't flip, just look at mine. Combinations are groups of the same thing. The total is the N, and the thing that you're choosing out is the R. So for example, just real quick, if I have 4 pens, how many different ways are there to make groups of 4 pens? And I'm not talking about arrangements, I'm talking about groups. If I have 4 pens, how many different groups of 4 pens can I make? One. There's only one group of 4 pens I can make out of 4 pens. Okay, that would be a permutation, honey. Okay, so what that means is right here under 4 combination 4, we know that answer is going to be 1. Okay, now notice here, there's nothing. Okay, how many groups of 1 can I make out of 0 objects? Yeah, that doesn't even make sense. Sure. How many groups of 2 can I make out of 1 object? Correct. That's the correct answer. It's nonsense. Doesn't make sense. That's why these boxes over here are not going to be filled in. Okay. So this part is also weird. How many groups of 0 objects can I make with 2 objects? 1. Okay. So let's just step away from the challenging part of that and see if we can develop some patterns in my table. What do you notice about choosing 0 objects? It's always 1. So we fill those in. Okay, can anyone else see another number pattern we can fill in? Connor.
I like the stair step that goes down if I want.
Yes, beautiful.
No, no,
Are you laughing at me? Any of you guys?
no.
Okay. No. Anyone else see another number pattern? But which one? Yeah, column 1. Okay, so if you think about this back to the pens, this is saying if I have 4 pens, how many groups of 1 pen can I make? 4. Does that make sense? This is one group of 1 pen, one group of 1 pen. Connor, you see another pattern?
9, 12, 15, 18.
I love you, but that's not how that one works. Yeah, well, it's wrong.
How about 1, 2, 3, 4, 5?
Yes. No, because the difference between 1 and 3 is 2, and the difference between 3 and 6 is 3. Uh-huh, it would be 10. 15. No. Okay, now do you guys see that 1, 3, 6 is also occurring here? Okay, anyone want to take a stab at this guy? This guy.
The one,
One below the 10 in column 3.
22.
Okay, I love your steps. Let's see what we get when we do 6 combination 3 on the calculator.
15.
Okay, now what I want you guys to see is that this is going up 3, this is going up 6. It's actually adding the pattern of this column. So it went up 3, then up 6, then up 10, then what should this one be? 35? Okay, so up 3, up 6, up 10, up 15, up 21. Okay, and then we can use that this way also. Anyone want to take a guess at this one? Last one. Up 4, up 10, up 20,
40. 75.
70. Okay, but let's check. Okay, now can you guys transfer these numbers down into Pascal's triangle down here? So this is 1, and then 1, 1, and then 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Yeah. What? Yeah, you're just copying off of this up here. But yes, all of that side parts are 1. 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So Pascal's triangle actually goes on forever. And you can keep going if you want, but usually our problems are contained within this much. So I'm going to show you 3 things. First of all, this is row 0, row 1, row 2, row 3. You can identify the row by whatever the first number is that's not a 1. So this is row 2 because the first number that's not a 1 is a 2. Row 3, row 4. Okay, and what I want you guys to do is on row 4 in the top, put a little 0, 1, 2, 3, 4. Just trust me for now. Okay, and then if you have a highlighter of any type, if not, it's totally fine. Just circle. What I want you guys to notice is that Pascal's triangle is actually made of some other patterns. There are not highlighters in those. No. Okay. You notice is that you will never need to memorize Pascal's triangle. Not something that anyone would ever need to memorize. The top number is 1. The second row is just 1 and 1. And then how do you get the rest of them? Well, the first one is always 1. And then what you do is you add the 2 above, and it becomes the number below. So 4 plus 6 is 10. 10 plus 10 is 20. 15 plus 20 is 35. You can make your own Pascal's triangle just for fun by addition. Let me show you how to make it back here really quick.
Oh my gosh.
Okay, so this is like college party material, okay? You know, you want to impress your friends. Okay, the row 0 is always 1. Okay. Row 1 is just 2 ones.
And then it's 2 in the middle.
Yeah, okay. Then row 2 starts with a 1. They all start with 1. Then you add these 2 and then a 1. Okay. Row 3 starts with a 1. Add these 2. Add these 2. 1. You picking up what I'm laying down?
1, try 4,
Okay.
6, 4, 1.
Done. You never need to write this on a note card. You never need, I mean, you can if you don't trust yourself, but if you can add, you don't need it. Okay. This problem, by the way, was 10-152. Okay, now flip back to the notebook and we're going to actually talk about why this is helpful for your life. Why, other than just fun number patterns, what does this do for us? Mhm. No, this is the only Pascal's triangle. Yeah, no, I'm not going to throw any other operations at you for this. This is it. Okay, so for number 153, we're going to expand this with the box. And what we're going to do is I'm going to show you how this relates to Pascal's triangle. So the first thing I want you to do is recognize that a plus b squared is a plus b, a plus b. And that is a 2 by 2 box. So make yourself a 2 by 2. To be honest with you, if I have a 2 by 2 situation, I usually will do the box because I find this to be easier than the binomial theorem. A squared, a times b, a times b, b squared. Look at us go. Yes. Yeah, you're doing some chemistry right now. Okay, so this is a squared plus 2ab plus b squared. Okay, and what I want you to do is I want you to take this and do what you would never do. I want you to put the leading coefficients on the first one and last one. So 1a squared plus 2ab plus, I just got distracted by Coach T and forgot my 1. One b squared. Okay, and then I want you to come back in if you have another color of some type. And take a look at the leading coefficients and then look back at Pascal's triangle. Where is that? Row 2. Okay, and I want you to notice the original problem has a 2.
Oh, so if it's cubed, then it's gonna be row 4.
Yep, three. Okay,
Zero. That one messed me up. Sorry, that was.
just remember, if you ever want to run something by someone next to you before you say it out loud, not a bad idea. Okay. Now, I'm gonna cheat a little bit. We're gonna do a plus b cubed, but I'm gonna use what I already did in the previous problem, because I already multiplied two of them, right?
Yeah.
So I'm not gonna do that over again. Let's not be dumb here. Is it okay with you guys if I steal my answer from this one and replace it with these two? So what I'm saying is these two multiply to be a squared plus 2ab plus b squared. And then I have the additional a plus b. Bless yous are always open. Okay, now what size box is this? Okay, so come down here. And really be careful with the alphabetical order here when you're multiplying. Put the A's in front and the B's in the back. It will really help you. Yeah. You see in the vision? Okay, so my goal is, let me tell you what the actual objective is here, if that's helpful. My goal for you is to be able to multiply out a binomial with an exponent on it without a box. That's what we're gonna do in C and in the note. Because once you get to the fourth power, I don't know about you, but the fourth power is kind of where I draw the line. I'm not doing boxes after that. Then binomial theorem becomes much more efficient to me. Cubed, it depends. Sometimes I'll do the box, sometimes I'll do binomial theorem. But the sixth power, heck no. I'm not doing the boxes for the sixth power. Like, absolutely not. So when you've got a big number up there in that exponent, that's when Pascal's triangle and the binomial theorem come in to help you, because you don't have to do all these crazy boxes. Yes.
Wait, so like, I'm just like, kind of a tiny bit confused, because like, I know this helps us, but like, what will we use it with? Because like, you know, how, like, are we supposed to say like row three? Or do we just like use it?
No, actually, to be honest with you, these first two were just to prove to you that I'm not making stuff up over here. So what I wanted to do was use our conventional methods of multiplying out to show you that I'm not just up here creating voodoo. Now I'm gonna say, okay, now that you trust me that this works, Pascal's triangle works, can I now multiply this out correctly without the box? Okay, so this is your Camry. This is your Corvette. Camry, Corvette. Okay, what that means is your Camry is there for you. It's reliable. Boxes are always there. If you need to do them on a problem to multiply something out, by all means. If you know how to drive, though, a fancier method that's a little more sophisticated, why not? Because it saves you time and it looks flashy. Okay, now number C. Okay, so we need to know first, what row is this going to be? There's a big clue right here. 4. Okay, now next question. How many terms will row 4 have? Look at your resource page. Look at row 4. How many? Yes. 5 terms. Do you see how there's 5 numbers in row 4? Are you with me? Okay, now what are the leading coefficients in row 4? Row 4. What are the leading coefficients? 1, 4, 6, 4, and 1. Okay, so the next thing I need to teach you is, okay, you know the numbers in front now. I've hopefully proven to you that that works. What about the letters? What's the pattern there? So that's the next thing you need to learn. Okay, so put your equals way over here. One of the things about the binomial theorem problems is they're long like this ways. So just put your equals over here. Okay, the first term is going to have a leading coefficient of 1 because it's the first number in my list. Okay, and can you guys all identify this as the front seat and this as the back seat? Okay, if I say front seat, will you guys know what I'm talking about?
The A.
The A. If I say back seat, do you know what I'm talking about?
The B.
Okay, perfect. Okay, so this is how the pattern goes. Leading coefficient in the first term, the front seat is to the full power of the problem. And the back seat is to the 0 power. Okay, plus. So I want to, my final answer should look something like this, by the way. This is what I'm going toward. I'm just going to do a step before that. Okay, my next number in front, my leading coefficient is going to be 4. What happened to the A value here? Between here and here. Between here and here, what does happen to the A? It went down 1. Okay, so the front seat thing goes down a power. And the back seat thing goes up a power. Notice each of the powers of these have a total of 4. Okay, plus. What's the next leading coefficient? 6. Front seat, down a power. Back seat, up a power. Maybe that would have been something to say to the person next to you.
Right.
Front seat, down a power. Back seat, up a power. Front seat, down. Back seat, up. Okay, now what I do is I cancel out anything that's a one. So this is a one, I don't care about it. B to the zero is a one, I don't care about it. Do, 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 do. This is a one, don't care. A to the zero power is a one, don't care. Okay. Right here, only thing left is a to the fourth. Okay, now how do I make this look pretty? I just put 4a cubed b. How do I make this look pretty? 6a squared b squared. 4a b cubed. And b to the fourth. Okay, we have one more problem. And we're going to do this with the sixth power. Now, this might seem like a lot to you. However, I want you to think about what would be involved if you had to debug this with the sixth power.
Yeah.
But I mean, the thing is, you'd have to start with a 2 by 2. Then you'd have to do a 2 by 3. Then you'd have to do a 3 by 4. No, 3 by 2.
Wait,
No,
2 by 4.
2 by 4. Then a 2 by 5.
2 by 6.
So you could do a 3 by 3. If you did twos and twos and twos, then you could do a 3 by 3, a 3 by 3. And then anyway, it's a lot of options.
4 by 4, because you know, like 16, but like divided by 4.
Okay. All right, last problem. Okay, think very carefully. What row is this problem? Row 6. How many terms are in row 6? 7 terms. You don't really need to add, you don't really need to like count them. You can just add 1. Okay, and then what are the leading coefficients in row 6? Also, did you guys notice about the symmetry in Pascal's triangle? Did you notice that if you cut it straight down the middle, that it would be the same on both sides? Just checking. It cuts our work in half because you notice how we did it like down and then diagonal. Okay, anyway. Okay. A plus B to the 6th. Here we go. I'm going to put my equals way over here. Okay. First, leading coefficient is 1 because it's the first number in my list. Front seat to the full power. Back seat to the 0. And notice, my 2 exponents add to 6. Okay. Plus. Okay, 6 is my next number in my list. Front seat goes down a power. Back seat goes up a power. Notice my exponents add to 6. Okay, plus what number comes next? Yeah, you're both right. Okay, so front seat down a power. Back seat up a power. Notice those add to 6. Okay. Four plus two is six, honey.
You're doing the one behind, right? It's like the one behind. I'm like, I'm how the low number, you know, I think, you know. Then four plus two. That's better than 15.
15 is the leading coefficient. That's in the front. It's different. Those are separate things.
Oh,
Okay, what's the next leading coefficient? 20. Front seat down, back seat up. Next, 15. Front seat down, back seat up. I just wrote that wrong. Six. Front seat down, back seat up. I'm glad it's easy for you. Please be kind. No, not even close. Okay. So I wrote out my whole dealio. By the way, if you're wondering what we're doing tomorrow, we're replacing the A and B with actual stuff that might be in other problems, like X and two and Y and 7B, and like, you know, what to do when there's just, it's something different than A plus B inside subtraction. Okay, anyway, all right. Now I go through and cancel out anything that's a one. Cancel, cancel. Do to do, do to do, do to do, do to do. Cancel, cancel. Okay. Are my cancelings okay? All right. So what's left here? A to the 6 plus. How do I make this pretty?
8, 5, 15.
Beautiful. Okay. I guarantee you that took us, I don't know, 1/5 of the time that it would take to do the boxes to get that covered.
I've actually, I mean.
Like a 2x2 and 3x2.
Oh, yeah, no.
What?
Like, what if I can give like real numbers to
It will. That's why you have to be super organized. So in these problems, neatness count and going slow and being careful count. Handwriting count a lot with these.
That's right.
So just saying, because a little negative or something like, yeah. Okay. Now, can you guys look at the homework, please, which is the quiz 3 review worksheet? Oh, actually, one more thing. Flip your resource page to the next page in the packet. Okay, what Miss Rice and I did for you was we made you, excuse me, a bunch of images of what you would see if you Googled Pascal's triangle. So if you went on Google and Googled it, these are a bunch of different things that you might see. They're all the same thing. This is just the regular like I did on the board. This changes it to combinations. So there's the math that we did to get these. Yeah, totally. That's why I didn't have it turned over. Okay, this is basically what we made on the other side. This is AP stats notation. So if you're taking stats, you're going to see combinations written this way. So this means 2 combination 1. It's not a big deal. And then down here are all of the expanded forms of A plus B all the way to the 5th. And we could add the 6th because we just did it, but we're not going to because we're too lazy. Okay, now take a look at the quiz 3 review. Okay. Yeah, the quiz is on Friday. There's only 8 questions on this. Okay. So there's 3 topics. The first topic is evaluating a geometric series. We're gonna go over the geometric formula and stuff again tomorrow in the 2 warm-ups. We do not need to find the number of terms, just evaluate. The second one is evaluate an infinite. There are not infinite ones in the warm-ups, but there were infinite ones in your testing week packet. You might have to like refresh your memory on the infinite. And then these last 2, you might need to wait because we did some of that. We didn't do the numbers. Yeah. So these last 2 might not be doable for you yet, unless you want to give it a go. The answers are on the next page. But tomorrow I will teach you how to do Pascal triangle when there's other stuff in there besides too.
Yeah, well,